welcome back to the workshop. The preamp is fixed. Now, we had a major noise problem that forced me to put this whole video series on hold until I was able to fix it. So I've spent the last couple of weeks trying to solve this problem, and I have solved it. So now we can finally move on to part 9 of the Tube Preamp Pedal Build. Before I explain what the problem was, here are a few short clips of the work that I did over the last couple of weeks trying to solve this issue. Okay, I've gotten all of the components out of the chassis here, and I'm going to make a couple of changes to the way that I'm mounting the tube sockets and the base plate. One of the things I'm doing differently this time is I'm actually going to rivet the tube sockets to this plate, which means that the tube sockets themselves are not going to be able to hold the plate in place, so I'll have to put a couple of additional holes in here to hold it into the chassis. I guess at this point, you know, that's kind of a minor thing considering how much easier it will be to mount everything on this base plate and actually wire up the entire preamp without ever having to install it into the chassis. I think it'll just make the whole process a lot quicker. I've also added an additional mounting point on the base plate here for some extra terminal strips. These are the vertical ones. And basically I'm going to run the filament wires and the high voltage wires from these terminal strips over to the tube sockets and to wherever else they need to be connected. And then that way, once everything is wired up, I'll use the other side of the terminals here to connect everything to the transformer and the power supply. Okay, so here's the new terminal strips. You can see there's a lot more room underneath here. That's going to give us plenty of distance between the filament wires and any of the sensitive input wires. And I've put these additional terminal strips here so that we can come out of our transformer onto here and then leave from here to the filaments. We can do the same thing with the high voltage. Bring our power supply wires up to one of these terminals and then send it out to the various power supply points on the terminal strips. And basically what that means is it's going to allow me to use shielded cable from those vertical terminal strips to wherever those wires are terminated. So you know, I'm doing everything I can think of to eliminate any possibility of any stray power supply emissions here. Well, I've got the filament wires installed, and like I said, I use this heavy gauge shielded cable here. And it's coming back to this terminal strip here. And now I've got that final terminal strip installed over those tube sockets. And you can see we've got a lot more space above that than we had on the last build. Alright, I need some shielded cable for these points where the high voltage is going to come in. But there is no cable in existence that would be the perfect fit for what I'm doing here. So I'm actually going to make my own shielded cable, and it's not as hard as it might sound. Basically what I'm going to do is I'm going to take some aluminum foil and I'm going to bunch the wires together and wrap the foil around them, and then at certain points these wires are going to come out of that shield so that it can go over to the point where it's tied in, and then you know, you'll have 3 cables together and then one will come out and you'll have 2 cables together, and it will be one continuous shield all the way to the end. I'll have a bare wire outside of the shield, and then I'll have some heat shrink tubing on the outside holding everything together. Here's our shielded cable. I still have to put the heat shrink tubing around everything, but I just wanted to show you how I was doing this shield here. Just wrapped some pieces of aluminum foil out, brought the wires out where they're going to need to come out, and then a bare piece of copper wire is twisted around the whole thing, and that'll get grounded. And here it is with both cables installed. Down there you can see the shield ground in this bottom terminal. And then from these points we'll tie in the power supply. Here's the preamp finished. Again, much cleaner layout this time. I'll give you a close-up shot here. You can see a lot of these wires are going straight from the terminal strips to the tube sockets. So we shouldn't have any of the interference problems that we had before. And again, all of this is shielded, so no concerns about that. So now I'm ready to put it back in the enclosure and wire up all the switching components again. Another possible source of noise was the power supply for the switching circuit. Because I was taking it off of the filament supply, the rectifier switching could have induced some noise into the preamp through the filaments. If that was the case, it probably wasn't contributing a whole lot to the noise that I was hearing. Most of that, I have to assume at this point, was because the turret strips were sitting right down on the filament wires. Anyway, because I don't want to have to do this again, just to completely eliminate any possibility of that causing noise, I've put an extra transformer in here. I've taken apart a 9-volt power supply. I'm going to put this in the chassis. Come on. I'm going to put this in the chassis right down here, and because of the way that this is oriented, the electromagnetic emissions are going to be coming this way and this way, rather than out toward from the sides. So it's not going to interfere with anything. I have also removed all of the shielded cable that was coming back to this switch, because I'm going to reroute that. Alright, it turns out I did have to replace the power supply board. The first power supply capacitor that I had used, in fact I think the first two, I'd have to look again, I think the first two power supply capacitors that I used in the original power supply board were 315 volt capacitors. I thought I was using higher voltage capacitors, but I guess I just grabbed the wrong ones. When I first fired this thing up just to test voltages, I was getting about 380 volts. And even after I wired up the tube sockets and installed everything else, it was still only dropped down to 330 volts. So these capacitors were subjected to overvoltage several times. I would be surprised at this point if they're not shot. I'm kind of hesitant to say it at this point, but it's possible that was the problem all along, and that I didn't even need to redo all the other stuff. Although I do like, the fact that these terminal strips are raised up off of the filament wires. Obviously that's just good practice. It was stupid of me before to leave it the way that it was. It probably also wasn't necessary for me to use shielded wire, but it's not going to hurt anything, and I just wanted to be on the safe side so that I didn't have to rebuild this thing again. So now what I've done, because I had to rebuild the power supply board anyway, I wanted to add a little bit of extra filtering. I have two 100 microfarad capacitors stacked with balancing resistors between them for the first stage, and then a small dropping resistor, and then the second stage is identical, and that's where our first power supply node is coming from. So these first and second stages will handle 630 volts now instead of the 315 that they were rated for before. When I had the bridge rectifier on this on the filament supply that was supplying the voltage for the switching board, the bridge rectifier was ground referenced. The filament wires were not, because you can't have both of them ground referenced, otherwise you'd have a ground loop. So I had to add these balancing resistors on the filament wires so that they would have a ground reference point. And since I was doing it anyway, I figured why not install a little trim pot in there. So right there's a little trim pot, and it's top mounted, so I can use a little screwdriver and adjust that. I don't know if I'm going to get any noise reduction from having that perfectly centered or not. I've done that before in other amplifiers, and I usually don't hear any difference. Because of the changes that I made to the power supply, it will no longer fit the fuse holders. So I'm going to have to get some panel mount fuse holders, drill a couple holes into this back panel, and mount the fuses on the back panel. Okay, so let me just summarize all of the stuff that I had to do to this. First, I thought the problem was the filament wires. It had nothing to do with the filament wires, although they could have been adding some of their own noise because they were really close to the turret strips that were in here. So I rebuilt the entire preamp section on these tag strips. Definitely a much better build than it was before. I used shielded wire in a lot of places that I probably didn't need to use shielded wire, but I didn't want to take any chances and have to do this again. I like the way that the power supply wires are connected to the preamp a lot better than I had before. These, the wires were just going straight from the power supply board over to their respective connections on the preamp. And this way, if I ever have to change this out again, it'll make things a lot easier. So, that is an improvement. The next thing I tried was to rebuild the power supply itself. And because I was using capacitors that were rated for a lower voltage than what we were actually seeing on the power supply, I thought, well, I probably just killed the capacitors, and that's what was causing all the noise. So I rebuilt the power supply board and made sure that everything could handle the voltages that it was seeing. I used more filtering than I had in there before. Because of the new size of the power supply board, I had to move the fuses to the back panel. So I had to drill a couple holes in there, pick up some panel mount fuse holders and put those in there. That wasn't the issue either. It had nothing to do with that. I put the new power supply board in there, wired everything up, and the noise was still every bit as bad as it was before. So at that point, my biggest fear was that it was the location of the power transformer that was causing, horrendous amounts of interference. I couldn't see how a shielded power transformer would cause that much interference. I figured, worst case scenario, I might get a little bit of hum out of it. But I thought, before I spend too much time on this, I really ought to check and see if this power transformer is causing interference, and that's the source of all this noise. So what I did was I decided to take samples of the audio signal from various points in the circuit, starting with the first tube stage. Now the ideal tool for this would have been an oscilloscope. It would have allowed me to see exactly what's going on inside there, but my oscilloscope needs some service. For one thing, you can barely see the screen because it's gotten so dim with age. I would have liked to use it for this, but anyway, I had something else that I was able to use. This is a box that I came up with to allow me to clip on to various points within the audio circuit and then send an output from there into an amplifier. And all it is it's got a couple of banana plug jacks here. You can use it with any probe. Just plug the probe in there and then clip this on somewhere in the amplifier. And basically, you've got one for ground and one for the actual audio signal. So you clip those on, and then it goes through a 1 microfarad 630 volt capacitor. So if you aren't able to find a spot to clip onto where it's already got a blocking capacitor keeping your DC from reaching wherever you're plugging into, that's okay. It's got its own blocking cap, and it can handle any voltage that you're going to see in a typical guitar preamp circuit. And then after this capacitor, it goes into a volume control so that you can attenuate the signal so you're not making your ears bleed. And then a couple of parallel 1/4 inch output jacks. So what I did, I clipped onto the first tube stage. I didn't hear any noise there. It sounded just fine. Clipped onto the second tube stage. Same thing again, no noise. And I kept trying various points in the circuit until I got to the output of the last stage, the cascode. And there was horrible, horrible noise there. All of the noise was coming from that point. Everything prior to that point, even at the input of the cascode, was dead quiet. Another thing that I noticed as I was auditioning various points in the circuit was that squashy, muffled kind of distortion that I usually associate with a blocking distortion, or at least approaching blocking distortion, was not there at any point prior to that cascode stage. So I decided, why not move the volume controls to before the cascode stage, because maybe that's where that nasty sounding distortion is coming from. So I moved, I ended up just getting rid of the rhythm volume control altogether, and just went to a volume control for the lead channel and then a master volume after the cascode. And as soon as I put that in, all of a sudden, the lead channel was quiet. The rhythm channel was still horribly noisy, but the lead channel was quiet because I had attenuated the signal at the input of the cascode. Now, a cascode behaves a lot differently than a triode, and there's a lot that I don't understand about them because there's just not a lot of information out there about them aside from, you know, how they operate and their use within preamp circuits that are intended to be used clean. Like, you know, you can find information about them as a phono preamp. So I don't know if this is just a coincidence or if this is just something that happens within cascodes when you drive the grid too hard. I didn't think it was going to overdrive the grid because of the insertion loss of the tone stack. Normally that's enough to bring it down to a safe level, and as soon as I dropped the signal strength going into the grid of the cascode, everything changed. It was so much quieter, and so I still haven't, there's still a little bit of room for improvement, and I'll probably put the volume control back in for the rhythm channel. Now, there was another issue that came up. As soon as I used the boost, it became noisy again. Not quite as noisy as it was before, but definitely a lot noisier than I would want it to be. And I think it may be because I'm not using a regulated voltage supply for the boost. It seems like that shouldn't be an issue, but I am getting more noise than I should, so I'm going to try that and see if that changes it. Now, last night was practice, so I decided to take this with me to practice and try it out on stage, and it sounded so good. There are a couple of things that I'd like to improve on, but it sounded great. I mean, it was some of the best sound that I've ever gotten there. I did use a noise gate, but you know, even when I was turning the noise gate off, it was pretty darn quiet. In fact, the weird thing is, even the boost wasn't all that noisy there, so I'm pretty happy with how this has turned out. I want to give you just a couple quick samples of how it sounds right now before we start getting into any improvements on this circuit. Now, I can't just go into the front end of an amplifier because then the EQ curve of that amplifier will stack against the EQ curve of this preamp, and you're not going to get a very good representation of the actual sound of this. So I needed to go into the power amplifier. I don't have an amplifier here with an effects loop, so I'm actually going into the reverb return jack, and I've made this shielded cable. It's got a couple of alligator clips on the end so that I can actually clip on to the positive and negative terminal on the reverb return jack, and then the reverb control actually becomes our master volume for this. So here's the preamp. Well, this is actually the preamp off right now. I'm going to turn that down a little bit because it's probably overdriving the camera mic a little bit. Anyway, that's our clean sound. The only thing that you're hearing is just the guitar going through the buffer and into the reverb return jack. So here is with the preamp turned on. Okay, so still a little bit noisy. We can improve on that. One of the things that I noticed, though, when I turn the reverb control down on this, it actually changed the tone quite a bit. It sounded a little bit more nasally with the volume down, but if I turn it up where it sounds better, it would definitely overdrive the camera mic. So I'm going to have to set up a better microphone here. First, I want to take care of something else that I noticed, and this is something that I kept hearing last night at practice. There's just a little too much low end on the rhythm channel, and it doesn't balance well with the lead channel because of that. I want to add a little trim pot in there on the cathode bypass capacitor for V1. Because what happens when you switch from the lead channel to the rhythm channel, on V1A, there is a 0.68 capacitor on the cathode it's always in the circuit. And then when you switch to the rhythm channel, it switches in a 22 microfarad capacitor in parallel with that. And so what I'm going to do is I'm going to put a little 5K trim pot in series with that capacitor just to allow me to blend in that capacitor a little bit more, instead of just having the full range on that tube stage when it's on the rhythm channel. Still have a little bit of the bass cut that you get from that 0.68 capacitor. Okay, I'm ready to order my speaker emulator circuit board, and this is the schematic that I'm working from. This is just an adaptation of an existing circuit that was in a Marshall preamp. So without changing any component values, it ought to be pretty close to what I need for a preamp like this. And here's the circuit board all laid out. This is going to mount to the back panel using the nuts for both of these jacks. I think the XLR jack has a couple of screws in the front that it uses to mount to the panel, and then of course this pot will secure it to the front panel as well. Since I've got everything laid out the way that I want it, I'm ready to run the CAM processor here and export all of the Gerber files that I'll send to the board house. So I've already got a CAM job set up that I've used for several other projects, so I'm just going to hit Process Job, and here are those Gerber files in a Gerber viewer. Now, if you plan on ordering any circuit boards,
it's really a good idea to get a Gerber viewer, because there are a lot of times there are things that you won't see in your CAD program, mistakes that need to be cleaned up, that you will see once you look at the Gerber file. So get a Gerber viewer. There are a lot of good free ones out there. They're not hard to find. So I'm just going to look through each of these layers individually and make sure that I don't see any problems. And everything looks good, so I'm going to zip these so I can send them to the board house. Now, whenever I'm ordering circuit boards for a prototype, I like to use Panda PCB, because you don't have to order a lot of circuit boards to get a good price when you go through them. And I've never had any problems with their quality. So let's go ahead and enter the dimensions for the board here. Let's see, length is going to be width. And these are in millimeters. Quantity, we'll order 10 of them. 2 layers, thickness, okay, surface, I don't need lead-free. Okay, so those look good. Make sure I've got the right region selected. And there you go. $5 for 10 boards, plus a little bit of money for shipping. So that's not bad. 10 circuit boards, and those are not small circuit boards. That's a pretty good size. $21 for everything, and lead time is 5 business days. That may change a little bit. Sometimes they get here a little bit later than that, but it's still fairly quick, and you know, you can't beat the price. So I'm going to go ahead and place the order here. Okay, so now I've placed my order. Usually what happens is within a couple of days they'll send me a link to make a payment through PayPal. It's pretty easy to deal with them.
Okay, so now we've got the circuit board for the speaker emulator ordered. I've got to place an order for some parts too, because there's things like the XLR jack. I don't have any of those in stock, so I'll have to order that and a couple more things. In the next video, I'll assemble that, we'll get it put inside the pedal, and then we'll be able to do some direct recording. I'm going to take a look around and see if I can find any free backing tracks that I can use, because you know, it's a little bit more interesting having some accompaniment than just me sitting and playing my guitar. Although if we have to do that, then you know, it'll still at least give you an idea of what this sounds like direct to a board. Since we're almost to the end of this series, I've been thinking about what I wanted to do for the next video after this is all done. And I think what I'm going to do is, I've got a couple of these circuit boards that I pulled out of an old PV PA head. And this circuit board was for a single channel within that PA head. And it had 2 volume controls. Actually, I guess it was for 2 channels, because you could mix the 2 volume controls. But anyway, 2 volume controls, a bass control, and a treble control. What's interesting about this is that this has those old Mullard tropical fish capacitors on here. I've always loved the way that those sound. Because of the layout of this circuit, it would be really easy to convert this to a distortion pedal, something like a Big Muff style circuit. With a bass and treble control instead of the typical Big Muff tone control. So what I think I'm going to do is I'm going to do 2 of these, because I've got an extra one of these circuit boards. They're both going to be the exact same circuit, but one of them is going to use these tropical fish capacitors. It's going to use these BC109 transistors, these metal can type transistors, really nice sounding ones, and some 1N949 germanium diodes. I'm going to take these tropical fish capacitors out of the other one and just use the regular capacitors that I use in everything. I'm going to use just a standard bipolar transistor, nothing special, and I'm going to use 1N34A germanium diodes instead of the 1N949s. And then I'm going to find out, is there any real difference between using the exotic, expensive components, all the most expensive stuff that you can find out there, and just off-the-shelf stuff when it's the same circuit. I think there will be a difference, but the question is it a big enough difference to spend the extra money? So hopefully we'll end up debunking a couple myths through that. But anyway, that's going to be the next video series that I do. That's it for this video, and we've only got a little bit left in this series, so like it if you like it, comment and subscribe, and we will see you in the next video.